Okay, boys and girls, so we are going to continue our lesson now. Mm, okay, we will continue. This is lesson number 21. It's about work lah, okay? So previously we learned about work. Work is what? Work is energy transfer. Okay, work is energy transfer. So work when we doing about the work, okay? So we need to make sure the force and the directions, the distance, okay? For example, we push with the force to make the object to move. So this is the new position for the object. So this is the distance. So when we applying the formula for the work, W is equals to force times distance. Please make sure that the force and distance, they are in the same direction. Okay, they are in the same direction. Can be in horizontal or can be in vertical, doesn't matter as long as they are in parallel lah, in the same direction. Okay, for this case, so here is a keyword at here saying that it leave. Okay, leave. So we know that this object, the fruit, there is a force pointing downward is called weight. If you want to lift it, that means that you also need to apply same magnitude of force lifting it up. Okay, so this one 3.2 is the distance that we move. So can you see that the force and the distance direction is in parallel? Okay, it's in parallel. So at here, state the energy stored by the foot that increases as the barrier increase. Okay, when we move it up, what is the energy stored inside the fruit that will also increase? Okay, here keyword we leave it. Okay, we leave it. So at here, it will have gravitational potential energy. We leave. That means that we're giving a certain height. So for the gravitational potential energy is the energy due to the position, due to the height, due to the height. Okay, so at here, the weight of the fruit at here is 140 Newton. W equals to the 140 Newton. And don't forget the weight is actually the force that we apply. Okay, the weight is pointing downward. Weight is pointing downward. You want to lift it up, you need to apply same amount of force. Okay, so this one 140 Newton pointing downward. Okay, show that the work done that you need to lift it from the ground to the platform is approximately what 450 joule. So work done is actually force times the distance. Okay, the force that we need to apply is 140, the distance. So from the ground at here, we lift it up until the platform at here, the distance is 3.2. So at here, we should times 3.2. Okay, 140 times 3.2. Your answer should be 448 joule. So we prove that it's almost equals to 450 joule. Okay, is that clear? Is it okay? Okay, so we proceed to the page number 9. Okay. An electric train is initially at rest at a railway stations. The motor causes a constant force of 360,000 Newton. So this is a force. Okay, to act on the train and the train begins to move. So it starts to move. State the form of energy gained by the train as it begins to move. Keyword at here is move. So at here, can you tell me what kinds of energy? So just now, the energy at here keyword is leave. Okay, this one is leave. So we know that is GPE. Then right now, the keyword is move. So what kinds of energy? Angeline, kinetic. Yes. Okay, it's moving, kinetic. Okay, kinetic energy. Okay, so 子画 also the same. The train travel a distance 4 kilometer along a straight horizontal track. Calculate the work done on the train during this part of journey. So can you do calculation right now? Do your calculation and then tell me your answer. Work done, force time distance. Make sure they are in the directions. So because this is just a horizontal track, so there must be the force that we apply, and the 4 kilometer is actually in the same direction. Okay. Zihua, how many zero? 1, 2, 3, 4, 5, 6. No. Zihua, no. Zihua is wrong. Angeline is correct. Yes, dear. Okay, Zihua, why you wrong, you know? Because you didn't consider the prefix. 4 km. K is a prefix. So at here, 360,000 times the distance. I think you are writing 4 only. Okay, dear all, kilo. Do not just look at the value, then you substitute. Kilo is times 10 power of 3. Okay, so your answer should be 1.44 times 10 power of 9 joule. So this is the correct answer. Okay, so please remember, check the prefix. Is there any prefix here? Okay, make sure the unit is correct. Okay, if let's say at here, they give you in cm, you also need to convert into meter. Okay, dear, here, mark it down. This must be in meter. Why must be in meter? Because your unit for the work done is in joule. Joule is in SI unit. That means that the force and the distance that we apply, the unit that we the value that we put in, okay, the unit must be in SI unit also. So this one, force must be in Newton, then the distance must be in meter. So you need to convert from km to m. Okay. Oh, okay. Okay, dear, here, mass of the train, okay, the mass of the train is 450,000 kg. Calculate the maximum possible speed v of the train at the end of the first 4 kilometer of the journey. Okay, after the 4 kilometer of the journey, what is the possible maximum speed? V. They're giving you m. So how? Try to solve it. Angeline, yes, correct. Okay. Zihua, do you able to get the answer? Crystal, Crystal, try. Zihua, what is your answer? Do you try? What formula can link? Actually, normally, when they asking you see B, okay, B, then they divided into 1 and 2. Most of the time, they will be related to each other's because they are under same question B. Okay, so which means that at here, if you don't have idea mass and V, what formula we can use, then you may think about this, whether we can use something, this information helping us to solve the second question or not. Okay, so at here, we can using the work done is to helping us. As I told you, work done is what? Energy transfer. Work done is energy transfer. Okay? So at here, moving, possible speed. So what is the energy? Energy is 1 over 2 mv squared. It's the kinetic energy. So at here, I know that this energy is actually kinetic energy. Okay? Okay, so at here I got 1.44 times 10 power of 9 is joule for the work done. Then I know that this object is moving, the train is moving, so it's kinetic energy. Okay, so at here 1 over 2, 450,000 V square. 1.44 is the work done times 10 power of 9. Okay, when you find the V, please remember square root it because 1 over 2 mv square. Okay, so press your calculator and be careful. So at here, if your answer correct, press your calculator correct. So you will get 80 meter per second. Okay. So for question B2 is actually 80 meter per second. Licious and Crystal okay, Zihua? Okay. Okay, dear, at here, I want to emphasize actually is the third question here. In practice, okay, the speed of the train is much less than the actual value. Okay, than the value that we calculate into. So just now we did calculation 80 meter per second. They say that in practice, in real life, okay, we really run this we really let it running, okay, moving. So we found out that the speed is actually maybe like 60 meter per second only. We can't really reach to the 80 meter per second. Can you think what is the reason for this is the case? Why? Teacher, we did calculation what? Okay, but why there is the speed doesn't able to achieve 80 meter per second in our real life? Why is only like 60 meter per second? So Angeline, what do you think? Zihua, your idea is correct. Energy dissipated to surrounding, friction, air resistance. Energy dissipated to the surrounding due to the friction and air resistance. Yes. Okay. So that means that the total energy that we have at here, this is the energy. But actually, this some of the energy we use to against the friction. Okay. So at here we can write work done. Some of the work done. Okay. Against friction. Okay, so energy converted to thermal energy. Or we say energy lost to the surrounding, okay, due to the friction. Okay, so energy convert to thermal energy. Wasted energy actually most of the time is thermal lah. Okay, but depends, some of the application cannot say thermal is wasted energy. For example, you having the water kettle, you want the heat, what you don't tell me that thermal energy is the wasted energy. Okay, it depends on the case, but most of the case wasted energy or energy lost to the surrounding, they will convert it to the thermal energy. Okay, here after traveling 4.0 kilometer, the train reached its maximum speed. Okay, it continued at this constant speed on the next stations of the track, where the track follow a curve. Okay, the track is curved, no longer a straight line, which is part of the circle. Okay, state the direction of the resultant force on the train as it follow the curved path. What do you think? Where is your resultant force, dear? Moving in a curved path. Okay, where is the direction of resultant force? Actually, this concept is in the previous chapter that we learned. This knowledge is about what? Zihua, yes. How about others? Crystal, Licious, Angeline, what do you think? Still remember, I give you the hints. Actually, this question C is related with the previous lesson that we learned about centripetal force. Centripetal force. Okay, it's a resultant force that can make the object moving in circular path. So right now the keyword is curve. Okay, curve. So when it moving in curve path, can you tell me where is the centripetal force should be pointing to? Angeline, any idea? Crystal, Crystal. Where is the centripetal force direction pointing to? If let's say you are here, okay, you're moving in a circular path in this direction, moving in this direction. Where is your centripetal force? No idea, dear? Okay, centripetal force, it will always pointing towards to the center. Okay, it will always pointing towards to the center. So at here, we can also say that perpendicular to the curved path, or we say towards to the center, towards center of the circle. Okay, we recall a bit, the knowledge, previous knowledge. They might be asking if this kind of question are moving in circular path. They might be asking you another question. Where is the direction of acceleration? Where is the direction of acceleration? Okay, dear, F equals to ma. Am I right? Your accelerations will be affected by your force. So directions for the acceleration and force are same direction. Same direction will be same direction. That means that your resultant force, or we say centripetal force, is pointing towards to the center. At the same time, your acceleration also pointing towards to the center. It follow. It follow. Okay, it will follow. Then what else the question will ask? If let's say they tell you that, for example, they tell you that the centripetal force is not enough to hold to make the object continue moving in circular path, where is your object going? Which direction your object will going? Actually, your object will moving in this direction. Follow the motion direction. Okay, object all the time will be trying moving in a straight line, in a straight line. Okay, moving forward. But at the end, because got centripetal force pulling it, so at any point at here, they will trying to moving like this. Okay, moving like this. But because got centripetal force, then hold it and change its direction, so it keep on moving in circular path. But if let's say one day, the centripetal force is not enough to hold it to make it moving in circular path, where the object will move. The object will going in this direction. Okay, teacher, why is going to the right? Why not going to the left? It's because I look at this. This is the direction how the object moving in clockwise, because I'm drawing in clockwise. That means object will keep on moving towards to this direction. Okay, perpendicular to the centripetal force. So actually, this question C is the knowledge that we have learned before that under the topic of centripetal force. Okay, until here, any question, dear? Work done is energy. Energy is work done. Sometimes, if they ask you to calculate work done, but the questions inside doesn't have force and S, then you can ask yourself what kinds of energy stored in this question. So maybe it is GPE, okay? Maybe it's kinetic energy. So you just using the energy formula to do calculation for your work done. Also no problem, okay? It's the same. They will be the same, okay? Because the first page of this worksheet, we did mention, okay, you do calculation for work done and you do calculation for the MGH GPE, you will found that it's the same answer. So the question, they might be not giving you the work they're asking you work done, but the question inside doesn't have any informations about the force and distance. Doesn't matter, okay? Use energy, related energy formula to do calculation. Okay, if the lesson number 21, no problem, we are going to lesson 22. Is it okay? I saw Crystal okay. How about others? Angeline okay. Licious?